morning, good afternoon, good evening, wherever you are, and welcome to episode 173. In this episode, we are going to be looking at some of the new features that have been added to the latest release of Cilium, which is 1.17. So let's kind of kick things off. As this is the Cilium and eBPF office hours, if you have any questions about Cilium, any questions about eBPF, Kubernetes networking, anything top of mind, then please feel free to drop those questions in the chat. So let me just bring my notes on. So pop myself down there. So yeah, as I mentioned, if you do have any questions, please feel free to drop those in the chat or just to say hi. As we always do, quick talking about events and current news. As always, we are getting very close to KubeCon EU, so I think we're about 23 days out. If anybody watching this now or afterwards as a recording is going to be at KubeCon in London, we will be present in the Project Pavilion as usual. So if you want to come find any of the engineers, any of the team who work on Cilium, if you have questions, ideas, want to know more about, kind of roadmap or anything like that, then please make your way over to the Project Pavilion and come and find the Cilium and eBPF project booth. I will be there as well, so hopefully get to see some of you at KubeCon in a couple of weeks' time. And then, as usual, the Cilium newsletter. I think Duffy covered the last Cilium newsletter in the last episode, so I don't think we really need to delve into it this much. So we'll probably just go straight into Cilium 1.17. There are a couple of places that we publish the release notes. So if you go to the Cilium repository and find the releases tab, you will find a list of all of the new features. However, if you want the full in-depth list of changes, then you can head to the changelog where things are kind of discussed in a little bit more detail. Given Cilium is quite a big project, it's kind of, or can be a little bit difficult to know, kind of what people may or may not want to know about new features have been added to Cilium. This release was pretty big. If I bring this in, we can see here, I'm only at E at the moment. That's all the way to W. There was quite a lot of changes that have been added to Cilium. So I've selected a couple. However, anybody who is watching who has spotted some of the certain changes in here that I haven't covered, then please raise them and we can kind of delve with them together. So, I'm not going to be an expert in all of these changes, but perhaps we can work out exactly how you make use of these new changes if they seem interesting for you. But let's kick things off. So Cilium version 1.17, one of the, I guess, major changes is that Metal LB has now been removed. So Metal LB has been bundled with Cilium for a very long time. I don't know exactly when it was originally bundled with Cilium, but from an end user perspective, it's kind of made use to have Metal LB there as an option that an end user can kind of quickly add to their cluster. Prior to some of the more recent changes in Cilium, if you wanted load balancer functionality with things like layer 2 ARP broadcasts or layer 3 and BGP, then these weren't supported out of the box with Cilium. You really needed something else to do that. So we decided to make life easier. We would effectively bundle Metal LB as an installable option that would sit next to Cilium. So, you can install Cilium and you can also say at the same time, I'd like Metal LB installing as well. And there we go. We've kind of taken care of adding that additional function for you. But as things have progressed and as time has passed, we've had People in the community add in functionality for advertising services and pods with layer 2 and with BGP. In fact, the BGP functionality in Cilium has seen a huge amount of work in adding new features, in supporting additional BGP functionality and things like that. And kind of one of the issues, I guess, if I were a product manager, which I'm not, but if I were to put my product manager hat on, it's always going to be difficult bundling along something else that is not something that you actually own to a certain degree. So if MetalLB has bugs in a release, because we're bundling along, we're going to get looked at and things like that. So we suddenly start to kind of incur a bit of technical debt, I guess, to a certain degree. So as I mentioned, as these new features have been added into Cilium, the things like the layer 2 service announcements, BGP peering, the functionality that originally was required and could be delivered by MetalLB, we can now deliver natively in Cilium itself. So since version 1.14, we have continued to bundle a MetalLB along with the Cilium installer. But now I believe we feel that we're at a point where our implementation is stable enough that MetalLB, we don't need to bundle it along with us. However, I mean, if you want to install MetalLB, by all means, go for it. You will just have to do that yourself. Just noticed I've got a couple of questions. So, what is BGP? That's a very good question, actually, I suppose. So, BGP is effectively what powers the internet. It's a protocol, so it stands for Border Gateway Protocol. So it's an open standard set by the UEFT folks, and effectively you use BGP to inform other network devices, things like top-of-rack switches that support routing, or routers themselves, that if they want to send traffic to an IP address or an IP address range, then send it to me. So for instance, you have a Kubernetes cluster, it has a bunch of services, you want to expose those services to the outside world, you would effectively tell the routing infrastructure that I hold those IP addresses. So if traffic is trying to get to an IP address, this particular IP address or this particular range that the services are in, then send traffic to me. So the routers are now made aware the traffic should come to them. And that effectively is a simplistic way of kind of how it all hangs together. The way the internet hangs together is effectively, you have tons of routers that all peer with one another, and they're all telling each other that, like this subnet, send traffic to me, and then, like I'll deal with routing it to everything that sits underneath and stuff like that. And effectively is what binds the internet together. When we're looking at BGP with kind of Kubernetes clusters, it's smaller environments and things like that. Does that explain your question? If there's any other protocols, please feel free to ask. Cool. I'll take that as a yes. And Tony is in the building. Hello, Tony. Hope you are well. So, as I mentioned, MetalLB has now been removed because effectively BGP and layer 2 advertisements, we feel, are pretty stable with the local implementation that now exists within Cilium. So one of the other new features that has been added is a capability of the controlling of bandwidth from a pod. So at the moment, or prior to this, pretty much, there was no kind of management in terms of how much traffic was flowing ingress and egress from a pod, which in most circumstances might not be a problem. However, I have seen this in other environments back in the day with things like slower zones and blah, blah, blah. The concept of a noisy neighbor. If you had a pod that was sending out so much traffic, it could theoretically cause other pods that are wanting to receive traffic or send traffic to become throttled to a certain degree. Or ultimately, it could potentially make a node unresponsive on the network, because all of that traffic coming from that one instance is starving the capability of other pods receiving or sending traffic, or even the host itself. So what has been implemented in Cilium is the concept of being able to specify the priority of traffic that is coming from various things within a node. So whether that's a pod, whether that's the node itself. Quite cleverly, what we have done out of the box is we always give the node the highest priority, because if the pods have the highest priority, you could be in a position where the node becomes unreachable. And if a node becomes unreachable, then it drops out of the Kubernetes cluster as being unusable. So got another quick question here. So how easy is it to get started to contribute to Cilium? I want to learn eBNF and Cilium for contributing. What things should I learn first? Some kernel coding, or do I go straight to eBPF? That's a big question. So I think from my perspective, the easiest way of contributing to Cilium would be, well, there's a couple of options ideally, but the Cilium developers do a fantastic job of labeling issues or largely issues, I suppose, to a certain degree, as with t-shirt sizes, so XL, medium, small, super small, etc. So I personally would probably go and there's a number of different places where you can kind of go, but additionally, there is things like a developers meeting that happens every week where the Cilium developers are on an open call and they talk about what's kind of happening with the Cilium project. So you could start there. You could go and join those calls, find out what is important, what the community is looking at adding to the Cilium project, gripes, if they were to have any with the Cilium project, and kind of learn from there to a certain degree, where it would potentially make sense to focus your energies. But additionally, as I mentioned, if you do go to the Cilium project on GitHub and look at the issues list, they're tagged typically with an idea of how big the problem actually would be, and start small. So go and find something that is that looks that is a small problem, that looks like it's something that you could potentially tackle. But then kind of feel free to bring that problem up at these community calls or on the Cilium Slack. Speak with the developers. And I've worked on a bunch of open source projects. The developers on the Cilium project are some of the nicest people. so that's always a good start. So speak about that you want to kind of get involved, and often they will kind of help point you in the right direction, and hopefully kind of get you started on your journey to contributing to Cilium. Now, you have mentioned eBPF twice. You don't need to learn eBPF to contribute to Cilium. Now, you can. The eBPF problems in Cilium, or the eBPF work in Cilium, or just eBPF in general, is complex. There's quite a large learning curve to learning eBPF, as it's not just tackling the Kubernetes side of things. It's not just tackling Go code for the controllers and for parsing things like YAML or doing other API logic. eBPF is deep kernel code that is going to be manipulating packets or modifying adapters and doing things like that. So my advice is start small if you want to. If you want to learn eBPF, then there are tons and tons of fantastic resources out there. I would look through some of the previous eCHO shows that we have done where we talk about writing eBPF code and kind of getting started as well. But yeah, if you want to contribute to Cilium, join those community developer meetings, join the Slack, and try and find a place where you can contribute. And everybody will be more than happy with a new face that is wanting to help out and make the Cilium project even better. Another one, quick one from Tony here. So since the integration with GoBGP hasn't needed to go back to MetalLB. So yes, for those who don't know, under the cover, MetalLB leverages a tool called FRR, which is something routing something. But effectively, it's a Linux program that takes care. It's like a daemon or daemon, depends on how you want to pronounce that. But effectively, it's another program that is used to do the routing, BGP peering, and things like that. Whereas in the Cilium project, we make use of a project called GoBGP, which is native Go. So we don't need to shell out to or depend on another program. So we natively in code will speak BGP protocol to top of rack routers and switches and propagate that information and things like that. Oh, another question. There's so many questions. This is fantastic. Is there anything in eBPF documentation online? Documentation online. Liz Rice's book, I believe, is available as a PDF. So if you go to either the Cilium website or the Isovalent website, I believe you will be able to sign up and get a PDF copy of Liz's book. If it's not there, then you'll have to go to Amazon, or you're a good independent retailer of books. But Liz's book on eBPF is a fantastic resource for getting started with writing eBPF code. And how long of a learning time are we talking about here? Well, that depends on you, unfortunately. eBPF, because of the requirements of things like the eBPF verifier and the eBPF runtime, you're going to have to write C code or Rust code, or there are a few other options. I think Zig is in a particular place where it might be able to create eBPF objects at this point. But you're going to need to start learning a little bit about kernel structures. You're going to need to learn a little bit about writing code that pleases the eBPF verifier. It depends where you are already with writing code. So it does have a steep learning curve, but once you kind of get going, and there are more and more resources coming out. There are a lot of good code samples on GitHub. I spend a lot of my time finding, spelunking, cave diving, whatever you want to call it, through various GitHub repositories, trying to find bits of code that I need, because that's a much easier way of learning how things hang together than just blindly reading through kernel documentation, which is not that much fun. Cool. As I say, if you've got any more questions, keep them coming. So yeah, the bandwidth manager. As I mentioned, so we have this bandwidth manager now inside of Cilium to ensure that noisy neighbors can't have a impact on the host, but also, if you have a workload that is latency dependent or can't be bandwidth starved for whatever reason, you can now effectively add an annotation to that with this new bandwidth.cilium.io/priority label or annotation. I think it's a label. There are 3 types of priority that you can apply, like highest priority, lowest priority, and a third one that escapes me. It's in the documentation. And once that is applied, effectively Cilium then will take care of ensuring that the kernel will guarantee, depending on the priority, will ensure a certain level of priority for traffic coming to and from that pod. So how does this work? This isn't using eBPF, although you we'll hear a little bit of technology that we talk about with eBPF quite a lot. So this is kind of a quick example of how it actually works. So it makes use of a kernel level feature, which is TC, or traffic control. Now, we talk about traffic control a lot in eBPF because that's typically one of the hooks where we actually attach our eBPF programs to traffic control. In this example, what we're actually doing is, so I'll put a quick example together at the top. And this is, imagine we had a pod that was sending huge amounts of data over SSH, so SFTP, to a remote location. That will effectively just take all available bandwidth, leaving nothing for anything else that's running on the box. So what we can do is we can add a new Q disk to the Ethernet adapter. So a Q disk is queuing discipline. So we can add that Q disk to the device itself. We can then add a filter to that device. And if we look here, the filter is to match traffic from a port, and then give it a flow ID so that if anything matches that, we can see it. And then finally, we can add a classifier to it, to that flow, that the traffic should be rated to 10 megabits. So with a ceiling of 10 megabits as well. So the difference here is the ceiling is how high it can go. So effectively, you can rate it to 10 megabits, but if nothing else is using any bandwidth, then it will use what is available in the ceiling. However, given that the rate and the ceiling are the same, it will never go more than 10 megabits. So this is how it is built inside the kernel to apply these behaviors on rate limiting traffic inside a Linux machine. And this is effectively what Cilium is going to do to a pod that matches. I don't believe we're doing it through flows. It's effectively just all of traffic coming in and out of that pod. So this is typically what it looks like. You have your applications that are running. They send traffic into the IP stack. The queuing discipline, so that Q disk, with its filter and its classifier, will see the traffic. If it matches, then it can do rate limiting, or it will take what is available, at which point then it will pass those socket buffers onto the driver queue, so effectively into the driver's memory of the NIC, and then the NIC will send that traffic on its merry way. I've got another quick question here. Only 9% of Cilium is C code. Is that all the eBPF stuff? Why is the majority Golang code? It's a good question. So this is Kubernetes we're doing. Got to write lots of Golang code, unfortunately. So there are a lot of parts to Cilium. The eBPF code is the bits that interact with the kernel and do all of the clever stuff. However, there is huge amounts of code required to do things like all of the service mesh functionality, things like the WireGuard functionality, the cluster mesh, there's a lot of things that are written in Cilium that are written in Go. It will use the eBPF code when it needs to actually make changes to the running system. So that's why it's a 9 to 90% split in terms of what the actual code is. Cool. Keep those questions coming. Static addresses for Gateway API. So this is, what I should mention, this functionality, the bandwidth manager with traffic control, is dependent on kernel 6.7. So you need a relatively new distro or a relatively new kernel in order for this functionality to work, I believe. But if you're running Ubuntu 24.04, then that comes with 6.8, so you should be fine. Yes, static addresses for Gateway API. So I briefly touched on this. So the Gateway API project, for those that haven't come across it, is effectively the new way of doing ingress/service mesh in the world of Kubernetes. And there's a lot of work at the moment. The project is rapidly evolving. 1.21 has just been released in terms of new Gateway API functionality. And this new change effectively allows us in the gateway object to have static IP addresses. Prior to this, it was a case of creating a gateway, getting an IP address from the load balancer service, and then kind of joining the dots yourself. Selecting load balancer algorithms. So there are a number of load balancing algorithms available within Cilium. At the moment, the default is to, you can either turn one on or off based upon the agent config. So basically, from what I remember, you can be either all the internal algorithm or all in on maglev for your load balancing algorithms. There is now an annotation that you can apply to a service which specifies which algorithm per service should actually be used. Why is this? Well, effectively, the maglev algorithm has a bunch of additional features. However, it is very resource heavy. So dependent on your use case, you can effectively you may want to have a bunch of services that sit using the internally implemented algorithm, which is a much lower footprint. However, for some services, you may want to depend on the maglev algorithm, which has a slightly bigger footprint for what it is actually doing. So I think those are kind of the main features that kind of sprung to mind. As I mentioned, there are a lot of new features that have been added recently. A lot of, as you can see, kind of here, a lot of new BGP function features that have been added. So there is a huge amount of work adding in additional capabilities of observability into what's kind of happening with your BGP. Capability of having better reporting into what's actually happening with your actual peering itself. That was a spot as well. There we go. Yeah, I know it spotted this. So deprecations as well. So whilst it is always good adding new features, we need to try and do our best to, as time passes, kind of reduce technical debt and clean up things that are no longer kind of being used as well. I believe I'm right in saying that Cilium originally started life as a plugin for Docker, and then obviously Kubernetes kind of took off. So yeah, the Cilium Docker plugin is now going to be deprecated and will be, I guess, moving to have kind of a full focus on Kubernetes and other workloads as opposed to Docker as well. I've got another question. How did you learn all this stuff? It's so complex. Please share your learning process. Well, I mean, it's a good question again. Reading, I think, is probably, as I mentioned, everything that we're talking about is all open source. There is nothing stopping anyone from, kind of taking the Cilium source code and building it locally, stepping through it. And as I mentioned as well, we have a large community on the Cilium Slack. So on there, you'll find a bunch of channels. There's eBPF developer channels where you can go in there. There's lots of people who are starting from scratch learning eBPF in that channel. They're always asking great questions. So you can kind of, if you don't want to ask questions, you can probably already see the question that you wanted to ask being asked. So you can kind of go in there and, find out what people are doing. Everything that they're doing is typically all open source. So you can kind of go and find that. This is a good point as well. So thank you, Matthew. Yes, eCHO 51, life of a packet. I think this is from Duffy, who effectively, will talk about traffic from A to B and all of the various layers that sit on top and things like that. But then understanding Kubernetes as well. So all of the workloads that we're typically managing the traffic from are running in Kubernetes clusters. So there's a lot of learning to a certain degree around Kubernetes and writing code to run in Kubernetes as well. So yeah, I can't lie, it's not easy, but I think we have a fantastic community. There are a million people there who are super happy to help you out. As Matthew mentioned, we have 173 eCHO episodes at this point, discussing the basics of network traffic, things like Gateway API, which I was talking about earlier, getting started with eBPF, getting started with Kubernetes services and networking and things like that. So there are a fantastic amount of resources out there, hopefully, to get you started. But if you have questions, then please join the Cilium Slack, ask away in there, and people will be more than happy to help you. Cool. So I think what was the other things that kind of caught my eye? There have been a large amounts of improvements for scaling. So we are starting to see big Kubernetes clusters these days. I mean, I know people talked about big Kubernetes clusters in the back. There was a Pokemon Go cluster back in the day, which broke because it hit the limits of kind of Kubernetes. But as people are deploying more and more workloads, we're seeing very, very big clusters appearing. So we've been putting a lot of effort into improving various footprints of the agents and scaling of those agents, so that Cilium will basically scale effortlessly with your larger clusters. Changes to observability. So we've had a huge amount of people in the community add in kind of various Prometheus hooks to get more and more information out of what's kind of happening with BGP, what's kind of happening with the eBPF programs. Gateway APIs, I mentioned, we support the latest version, which is 1.21 now of Gateway API. This is a nice change because this always catches people up. So if you're using Gateway API, you typically will need to install the Gateway API custom resource definition first from the Gateway API project. Because if you don't install those, the Cilium controller will start up and it won't know what a gateway object is, and it won't know what a HTTP route is, and it won't know what a gateway class is. We now have auto detection for that in place, where it will effectively take care of ensuring that those custom resource definitions have been added to your cluster, so that Cilium actually understands what's going on when it's trying to apply those sorts of things as well. So yeah, I think, as I mentioned, there is a lot of additional changes on here. I think there was, did it say in here or not? Bear with me a second. I'm sure it says it somewhere. Oops. Sorry about this. Here we go. Yes, so 2,761 commits in the 1.17 release. I think I've chosen 7 or 8 of, I think, the biggest kind of changes that have been added. There's a lot more in here as well. So this is quite nice for, I guess, smaller environments where you want to share a port across different services. So if you had something on TCP listening on port 80, you can have a different service that uses port 80 but UDP, and there is now logic to ensure that those won't conflict with each other, so you can effectively have 2 services with different use cases sharing the same port and things like that. So I think that's pretty much everything that I wanted to kind of go through. Your homework, if you want to learn more, is to sit and read through all of the release notes to find anything that is of interest to you. I don't know if you spotted as well at the top, though. We are already, the top. Yep, here we go. We are already starting work on 1.18. So this is pre-release. However, if you want the latest and greatest and want to take it for a test drive, then you can deploy the pre-release of 1.18 at the moment. If you do have any bugs, or if you don't spot any additional features, then raise issues, bring it to the developer meetings, which take place on a Wednesday. Yeah, feel free, get your hands dirty, let us know. So I think that's pretty much everything that I was aiming for at the moment. I don't know if we've got any more questions. No, I think we are all good. In all of the notes, I've added in a bunch of additional documentation. What is maglev, if you want to learn more about that. The docs for doing things like the gateway API stuff. This is a deep dive into traffic control. So if you really want to learn all about the classes, the queuing disciplines, how traffic control works under the covers, I've added all that in there for your perusal. Along with, there's a really good blog post which kind of details kind of putting this all together, and the changelog and things like that. So as mentioned, if you are at KubeCon and you want to meet the maintainers and the contributors, we'll be there. Please come find us, either at the Icevalent booth or the Cilium project booth in the Project Pavilion. However, we are all in the Cilium community Slack. So if you head over to cilium.slack.com, you can join and find us on there with your questions. Yeah. With that, I'd like to thank everybody for joining this week. Thank you for all of your questions. There's questions about development environments. I'm not going to get involved in that sort of question because that can get very... all I'll say is choose a development environment that works for you. So, yes, thank you very much. And I will leave it there. Thank you, everybody, and enjoy the rest of your day.